today we are going to be solving exponential equations using, apparently it's advanced. Ooh, scary stuff right here. Now, we're going to do a quick little review of what needs to happen in order for us to solve for x when it's up here in the exponential realm. All right, so here we go. Let's do something easy. Ready? 2 to the power of x equals 2 to the power of 7. This would be easy. What would x have to equal in order for this equation to be true? What would it have to equal? It'd have to equal a 7. So in order for this to work, what do we have to have? We have to have what's called the same same base. All right. Oh, man. These aren't the same. Bummer. So what we're going to do is we are going to convert a 27 to something. Well, you know what? 3 cubed is 27. So the first thing I want you to do in your journal right now is convert the number 27 to 3 cubed. I've not changed the value of the number, just changed the way it looked. Now right up here, put 5x minus 4. And if you would, please, just add a little parentheses to it. Please, just do it. Now I'm going to change colors. So you know I'm working with a different part. So over here, 81. I'm going to change 81 to 3 to the power of 4. Why 3 to the power of 4? Because I had to find the same base. So yes, 81 is 9 squared, but I couldn't use a 9. I had to use a 3. So 3 to the power of 4. Now what's already sitting out there? A 7x minus 2. Well, now that you got the same base, and what base did we change everything to? Base 3. Now what can I set equal to each other? Now I can set this right here equal to this right here. So here's how I set it equal. I do 3 open parentheses 5x minus 4 equals 4 open parentheses 7x minus 2. And I close it. Now once we do this, what do we have to do? We have to do the distributive property, right? Why are we doing this? Because we have a what? Power to a power, which means you have to multiply. So I have 15x minus 12 equals 28x minus 8. Whew. Not pretty, but you know what? It'll be right. So where do I move all of my x's? I got 15 on this side and 28 on the other side. I'm just going to move everything to the right-hand side of the equal sign. So I'm going to take away 15x, and I'll take away 15x, and it looks like that gives me 13x. And then I will add an 8, and I will add an 8, and that gets me a negative 4. Whew. This is an ugly looking fraction. And then what are we going to divide both sides by? 13. Wow. So x, after all of that, x is equal to what? Negative 4 over 13 in order for these to be equivalent. Now, if you really wanted to check your answer to make sure that you got it right before you typed it in, what could you plug in right here and plug in right there? Plug in that negative 4 over 13, and then whatever decimal equivalent you would get here, you'd have to match the decimal equivalent over there. So let's do a quick review before I type the answer in. What was the first step? I had to change a 27 and an 81 to what base? To base 3. This was 3 cubed. This was 3 to the power of 4. Then we take the exponents that are up here. We multiply that guy out. We multiply this guy out. And once you do that, you solve for x. So we got negative 4 over 13. Whew, let's cross our fingers and our toes. It's an ugly fraction, but there it goes. All right. Ooh, interesting. This one looks more complicated. I guess that's why they call this advanced. I know. Yes, I'm a dad. I have plenty of bad dad jokes. That's what I do. All right. Put times 32 to the power of x plus 1 equals 2 to the power of 6x minus 7. So write that down nice and neat. So now, after you have it written down, you scan the bases and you ask yourself, what base do you think we need to convert everything to? We're going to base 2. That's base 2, right? So how do we convert a 32 to base 2? All right, so here's what you do. You kind of need to know your 2's, all right? Like, I mean, 2 to the power of 5 is 32. But you kind of need to know, like, 2 to the power of 4 is 16, and 2 cubed is 8. So if you wanted to make a little chart in your own journal or whatever, just so you kind of know your 2's and your 3's and your 4's, you could do that, all right? Now, right here, I'm gonna go down on the blackboard here, all right? So guys, so instead of 32, I want you to write 2 to the power of 5. And then right here, I want you to bring down the x plus 1. I'm going to put x plus 1. Then I'm bringing down 2 to the power of 4x minus 5. So I'm bringing down 2 to the power of 4x minus 5. Make sure you put a big old little dot multiplication and then set it equal to 2 to the power of 6x minus 7. All right. So we have these there's that multiplication. Now, you're going to have to distribute that 5 to both terms. So what's that going to give us? It's going to give us what? 5x plus what? What do you guys think? 5 times x is 5x. 5 times 1 is 5. Very good. All right. And then I got to bring this down. Good old multiplication. Okay, so this is what you should have right now. What we've done, all we've done is converted what? We've converted the 32, which we had right here, and what did we convert it to? 2 to the power of 5. Now, what do you guys remember about what's called the product property, where you have like b to the power of m times b to the power of n? Anybody remember what we can do with those exponents? You may remember? Add, yeah, we can add them together. Well, are these the same base right here? Well, guess what we can do with this and this? What do you think we can do? What do you think? We can add them together. So what is 4x plus 5x? 9x. Ooh, this is nice. Look at this. What does that say? Negative 5. What does that say? Those just cancel out. Oh my goodness. We're almost done. All right. So what did I do? I used what's called the product property, added those together to get this. So now what can we set? Finally, what can we set equal to each other? Equals what? 6x minus 7. Just set it equal to each other. 9x equals 6x minus 7. So what do we do to both sides? Take away a 6x, take away a 6x. We get 3x equals a negative 7, and divide both sides by 3, and we get x equals negative 7/3. And that's it. So what made this more difficult? Was this step right here, right? Like, what do I do with these? If that says multiply, what can I do with those? Add those together. And then what did we also have to do? We had to convert what? This 32 to 2 to the power of 5. All right? And it looks like I wrote everything down right, so that makes me feel good, because usually the only time I get these wrong is when I write things down incorrectly. So what am I going to type in? Negative 7 over 3. All right, let's type it in. Negative 7 over 3. Roll the dice. Nailed it. Okay. Ooh. By the way, what property do you think we're going to be using on this one? the division, but we call it the quotient property, okay? So here we go. I want you guys to write this down. 5 to the power of 6x plus 5 over 125 to the power of 3x minus 1 equals 5 to the power of negative 5x plus 2. All right, just take your time, write it down nice and neat. Think I got everything written down correctly? Yep. All right, now, really the only thing we got to do that's kind of tricky is this part that part right there. Does anybody know what I'm going to convert 125 to? 5 to the power of what do you think? It's not 1. It's not 2. I wonder if it's 3. 5 cubed. So here's what I'd like you to do. What I'd like you to do right now in your journal is just go. Well, you know, if you had pencil, you could do that. But if you're writing in pen. Oh, well, I have a student who's writing in pen right now. Well, that's okay. You can just rewrite it. Okay? So all I did was do what? Take what? That 125, right? And change it to what? Put parentheses and do what? Change it to 5 to the power of 3. Now, what do I have to do with the 3 now? I got to do power to a power. So what do students mess up on? They'll multiply it to the first one, but they'll forget to multiply it to the second one. So here we go. We have 5 to the power of 6x plus 5 over 5 to the power of 3 times 3 is 9. And 3 times negative 1 is negative 3. And that's all equal to 5 to the power of negative 5x plus 2. Now, you guys remember we talked about the quotient property? And the quotient property states that if you have the same base and you're dividing exponents, what are you allowed to do with these two exponents? We're allowed to do what? Simply subtract. So what are we going to do with these exponents right here? What am I going to do with this guy and this guy? I'm going to subtract them. Well, how do we subtract them? Here's what you do. Ready? Let's go ahead and do it right now. Ready? 6x plus 5. And what are we going to take away? We're going to take away a 9x minus a 3. And what are we going to set that all equal to? What's it all going to be equal to? Yeah, negative 5x plus 2. Now, what's the only difference between this problem and the last problem? What was the last problem? What did we have to do with the exponents? We had to add them. This one we had to subtract them. All right, so how do we subtract? It's very easy. You just multiply that negative. You got a negative 9x, got a positive 3. Here you got a 6x plus 5, and that's all equal to negative 5x plus 2. By the way, this is now what kind of problem? It's just an Algebra 1 problem now, okay? Just got to add your x's together. We have 6x minus 9x, that's negative 3x. We've got 5 plus 3, that's a total of 8. All right. So where do you think I will move all of my x's? No, not in Texas, but where am I going to move them? Got to move them over to the left. Now, how do I move them over to the left? Just add 5x to this side, add 5x to this side. Bless you. Bless you. Got a sneezy here. All right. What does that get? That gives me what? 2x minus 8. Because if it's a positive, you got to take it away. I got a minus 8 from both sides. 2 minus 8 is negative 6. Whew, I'm almost done. Like, it's just so close, I can just see the finish line. Not in my teaching career, but in this problem. Divide both sides by 2. And what is x equal? That's what I got, negative 3. So hopefully I didn't make one little tiny silly mistake because that was a lot of work. All right, hopefully I got everything right. Just taking my time. Something my dad once told me, he said, slower is faster. Because if you do this correctly the slow way, well, not the slow way, but like carefully, you won't have to redo it. All right, so let's do a quick review. What was step 1? Change the 125 to what? 5 cubed. Then multiply those together. We got 9x minus 3. Then we subtracted those. When we subtracted those, we got this right here. And then we solved for x and got negative 3. All right. All right. By the way, I'm not going to do this one, guys. Why am I not going to do this one? Because that's basically similar to our very what? Very, very first one. You see how that was a 27 and an 81. I changed it to what? Base 3. What would I do if I did this problem right? Not here, but right here. I changed that to base 3, and I changed that to base 3. Now, what I will do is I will go around the room, and I will help you change whatever base you need to change and get it to the correct base, okay? But that's it. Have a good day.